Okay, so on the table here, what I would propose, so eventually, again, this is probably what you're going to do a little bit tomorrow when you're on your own. If I give you this function, you could, if you want to, make a whole bunch of x values, 0, 1, 2. Go ahead and write that, actually. I do want you to write these. So there's no real way around this. Although I don't know if we want to use those. Yeah. Either way, we want to have those table of values. What you would need to do to now get all of these values, you would need to take this x value as 0 and substitute it in to see what it evaluates to be. You would need to take 1 and plug it in, 2 and plug it in, 3 and you would need to plug all of these values in and evaluate it on your calculator to figure out what they are. That obviously will take a very, very long time. So I've shown you how to do this on the calculator. So that is absolutely how I propose you do this when we eventually get to a quiz, when you do this tomorrow in class, is to use your calculator. So on your calculator again, plug that equation into your calculator. If you don't know how to do it, raise your hand. One of us can look at that real quick. And by plug it in, I mean act like you're going to graph it. So that's that y equals button right here. And then you're just going to plug that equation in. All right, without a calculator, without being able to do it this way, I mean, this problem would take you 10 minutes all by itself. So plug that in. If you don't know how to do that, let me know. You don't have a calculator, your time is coming where you're really going to need one. You're going to have problems. All right, we don't necessarily need to graph it yet. All right, once we have that in, what we really want is a table, right? That's what Carlos is doing. He's going to do a table. The calculator does the table for us. So our table is, again, let me make this nice and big. The table is right here, right above the graph key. It's in blue, it says table. Because it is in blue and it's above that key, you want the second function, table. Let me change mine. I have it set up a little bit differently than yours. Yours should be fine, I would hope. All right, so now go second table, and then we have this table of values. All right, but what we have to remember is sort of what are we looking for when we're doing a table, when we're doing these problems. So as I look through this, go ahead and go through 6. All right, so go 0 through 6. So do that for me real quick. So do the negative 15 for 0, negative 16, negative 15, negative 12, 4. All right, and then let me take a picture of this so I can write it when I close this. All right, so then... All right, so we should have this. All right, and then stop at that 6. All right. What we talked about when you're solving a table. So when we solve these quadratic functions, you can think of them in a few different ways. We have solutions. That's one of the words that we're going to use, and that's what you're told. But we also said that these are called zeros. So what that means in a table, look at this table right here. What we are looking for is a point that looks like this. This point right here, where we have an x value, and at that x value, notice how that y coordinate is a 0. What that tells us is one of our solutions, if we do it Carlos's way, which is to set up a table, one of our solutions is the x value of 5. Because that's where we get a 0 value. Okay? Now, there is another one, and that's why, again, if you don't have a graphing calculator and you can't do this on your own, this would take a very, very long time if you could do it at all. Because what we now need to go to your calculator. So this is the one that I told you is your solution. Find your other solution. Because right now, if I'm looking at this, do any of the other y values have a 0 on it? No. So find that other one. See if we would understand how to kind of play around with this to figure out where the other solution is going to be. All right, Katie, what was it? Good. So what he's saying is the other x value is a negative 3. So if I want to get to a negative 3, what he had to have done is just start kind of searching. There's a negative 1, you get negative 12. Negative 2, you're going to get a negative 7. The reason negative 3 is our other solution, doesn't that give us a 0? So the point, negative 3 comma 0, and that's why just kind of doing this without your calculator, we could have done a lot of work there for no reason. The other 0 is at negative 3. So this is your other solution because that's where the y value gives you a 3. All right. So our two solutions in this problem are 5, or not 5, and 0. 5 and the negative 3, because that's where the y value is going to equal a 0. All right. So if I give you a table tomorrow, if I give you a table on a quiz or on a test, what you are looking for is where that y value is a 0, whatever that is, those are your two solutions. Okay. All right. The graph we're going to do last. So let's do, so which one have we done here? We did the table. So that one's all set. Find Clarita, and let's do the factored form. So wherever Clarita is at, rewrite that equation. So where is she? She's down here. And that equation was f of x, right? Yeah, equals x squared minus 2x minus 15. All right, now understand how these are related. It's a little different method, but understand how these are related. If we want our solutions, weren't we looking for when the f of x here had a value of 0? So what that means is in your equation, let your f of x be a 0. So let the left-hand side be your 0. So this is when we set them equal to 0, and we're going to solve that. All right, factoring. So go ahead and factor this. This should be a nice one to factor. This is one that factors. All right, Armando, what were those numbers? Good. X minus 5, x plus 3. Those multiply to be the negative 15. If you add them, they're going to give you a negative 2. And then now understand what our answers are, right? Our answers have to be the same in all 5 of these methods. They better be 5 and negative 3. In every one of these 5, all 5 people should get the same exact thing, just doing it a different way. Because this is now when I would ask you, what factor makes this, or what number makes this factor 0? And that should be a positive 5. And then I would ask you, what number makes this factor equal a 0? That would be a negative 3. Same two answers that we got the other way. So as we started doing this yesterday, we didn't do the graph, we didn't do the table, but we talked factoring is the nicest if it factors, because this is very, very quick. Okay. However, let's say the next one I want you to do. So we have done the factored form. Find Tia. Tia is going to put it into vertex form and then do the completing of the square. So Tia is below. So write that same equation. Similar to the beginning of that previous one, we ultimately need to set that equal to a 0 because we're looking for when x gives you a y value of 0. So I'll erase that f of x. We want that to equal a 0. Okay, so she feels like completing the square is the easiest. So that's what we're going to do with this one. So completing the squares, when we did x squared minus a 2x, and then we'd kind of ignore the negative 15. We would draw that little square rectangle, the square with the 4 different squares. Go ahead and write in what do we add right here. If you want to draw it out, go ahead. What do we need to add to make that a perfect square? That little right-hand corner, if we were to draw in the square with the 4 corners. All right. All right, do that real quick. This is one that I worry about the most. Typically, people do factoring quadratic formula somewhat nicely, at least know the process. All right, what do we add there to, if I finish this little square model off over here, Monica, what number are we adding there? Good. Should just be a positive 1. We have a negative 2x. Those have to get split evenly between these two corners. So each one of those is a negative 1x. That means I have x minus 1 on top, x minus 1 on the bottom. If I add 1 to complete that square, that means I need to subtract 1 here. And then what we end up with now, notice what we had, x minus 1 times x minus a 1. So we write this as x minus 1 squared, and then minus that 16. From there, we now got to do a little bit of work. because now when we solve these with squares, we always isolated this thing. We want to get that by itself so we can do that square root. So to do that, we want to add the 16 over, and we get 16 is equal to that x minus a 1 squared. We did revisit this a little bit yesterday for the first time in a little while. What we talked about is to get rid of a square, that's when we do the square root. That means on the other side, I've got to do the square root as well. This is when we talked about this being a positive and a negative solution. So what we end up with is x minus a 1 equals a positive and a negative 4. I'm going to move over here because I've run out of room on the bottom of my paper. This is when we set up our two equations. I'm going to take the positive 4 and set that equal to x minus a 1. And I'm going to take this negative 4 and set that equal to x minus a 1. And there should be no surprises in the two answers here. If I now solve each of these, add that 1 over, that's going to give you your 5 that we know we're supposed to be getting. If I add 1 over right here, that will give us the negative 3 that we know we are supposed to be getting. Okay? That is completing the square and then having to use your square roots to go through that process and solve. Okay? All right, next one. Whoever this guy was. Tahani is the quadratic formula. Do that one then. It's what we've been doing now recently the most. So the quadratic formula, we know what our answers are. So if you don't get 5 and negative 3, you know you screwed up. All right, and then see if we can kind of figure out what happened from there. So do that one. And then we'll talk about the graph. The internet was fine. The internet was good, I think.
Yeah.
Okay. Look fine on mine. I didn't get an email about it though.
I tried to go back and scour it. It took a while for it to get through, but it eventually did.
Okay.
It stays that way.
All right. Hopefully we're getting there. Now that I have looked at these quizzes, so now I kind of see sort of some things that were issues. They weren't too bad overall. Just make sure this is a positive 2. This is always the opposite of B. Our B was a negative 2, so make sure you're changing that sign. All right, some people are not doing that. So whatever the B is, we're going to change that sign. Then this is our B squared minus 4 times A times C, and then all over 2 times A1. All right, this is fine when we're doing these. Not bad. We've talked about this every problem we've done with these. For the most part, we're getting this sign right. But again, some of us, eventually when we get that quiz back, we'll see we're still messing this up a little bit. But this should be a negative 4 times a negative 15, and a negative times a negative should be positive. And then that gives us 60, and then all over a 2. I've mentioned this a bunch of times as well. As long as it factored, which it did, we just factored it over here. That means you better get a nice number under here. All right, we should get a nice perfect square that we can work with easily. And in this case, that's the square root of 64. All right, we know that one. That's why it's a nice one. So we're going to get that 2 plus 8 divided by 2, and then you're going to do 2 minus 8 divided by 2. And then that's how we should get our two answers. So one answer is 2 plus 8 divided by 2. The other answer will be when we do 2 minus 8 and divide that by 2. So this is 10 over 2. That gives us the 5 we're supposed to get. This is a negative 6 over a 2. That's going to give us the negative 3 that we were supposed to get. All right. That hopefully we got. All right. And if not, kind of see how this is all playing out. We want to get a handle on that soon. All right. So last one, go up to the graph, graph everything that you can right now in this graph, because you have a lot of information on this paper already. Everything we need to draw a pretty good graph, we've already done the work for somewhere on the paper. So graph this. If you have your calculator, you can use it, but everything that you have on your paper right now, for the most part, should allow us to graph this. You have to be somewhat creative for one of them. All right, let me ask you a few questions now and see if we've picked up on what we should be able to get. I should be able to ask you your vertex, and there's multiple ways you could tell me what the vertex is based upon what we've already done on our paper. All right, what is our vertex? What do we think? Jake? Yeah, sure.
X equals -5.
Vertex, though. Remember, that's the highest or the lowest point.
Oh.
And there's a couple ways we can do it right now.
X equals -16.
We're getting warmer. The negative 16 is part of that. Ben, you had your hand up. Can you finish that off?
1 -16.
Good. So 1 comma negative 16. Where'd you get yours from, Ben?
This is in between -15.
Good. So find this point right here. If we went further back, we could kind of see a relationship, but notice how it's in the middle of a negative 15 and a negative 15. If we use our table and the calculator, these values, 2 in front and 2 behind, will have been a negative 12. That is your vertex. Also, go down to Clarita's method. Didn't Clarita put it into vertex form right here? Now, we rearranged it a little bit, but at this point right here, isn't this telling us our vertex is 1, negative 16? All right, so that's the other way that you could have done that when we put it into vertex form. So now, this is what I was mentioning. You got to be a little creative. We're going to have to guess a little bit. So extend this down. Also, eventually, you're going to determine best methods. This is one of the things that makes graphing a little iffy. If it's not a nice set of values that fit nicely in a small XY plane. But it's way down here. All right, other good things. You have a table of values right here, correct? You could just plot all of these points. The key points, though, at least in my opinion, the key points, if I can get this to work, are these guys. So go ahead and plot those guys, because now that's 5, 0 and negative 3, 0. And what that should allow us to do is draw in this parabola, which is what all these quadratics are. So tomorrow, if I give you a graph and I ask you what are your solutions, if this is all that I gave you, every single time we did this problem, we did it 4 different ways already. Didn't we say one answer was a 5 and then the other was a negative 3? All 4 ways that we've done it so far. So now look at your graph and notice what's happening at the x value of a negative 3 and the x value of a positive 5. All right, that is this point here. That is this point here. It is not a coincidence that that is where we are crossing the x-axis. So if you have a graph, if you have it already, all we have to do is look to see what x values do we cross the x-axis at. Those are your 2 answers with no work whatsoever. All right, if you have the graph already. If not, we got to construct that and put all that together. Okay? All right, so now go to that next one. We're going to do a little bit of this one here. Go to that one. Do your table. So graph it on the calculator or put it into the calculator. Look at your table. remember what we are looking for. The answers to the previous one were when your y values were 0. So put that into the calculator. Find when the y's are equal to a 0. Okay? And then those would be your two answers. All right, but you're doing it with this one now. Okay, anybody find them yet? All right, kind of a trick question. So let me go to mine. Here's the equation. Let's go to my table. So you don't all, oops, so table here. We're looking for when y equals a 0, right? So we're going to search for that value. No y is a 0, no y is a 0. You want to search a little bit. I wouldn't give you anything like a negative 30 or anything. So once you start seeing that that's not going to look like it gives us a 0, as we start searching around, was anybody able to find any zeros? No. All right. So what this one now kind of gets into, and this is ultimately sort of what you're going to do for the homework on the next page. When it says choose your best method, the table is really hard here because we don't get a 0 at a nice whole number. So in terms of trying to find zeros with a table, this is a problem. All right. Trying to do Carlos's way is a problem if it's not a nice whole number. We don't know what those are by looking at a table. Okay. So let's try Zach's way. Zach likes to graph it. When we graphed it on the previous problem, all we are looking for is when did the graph cross the x-axis. So go ahead and hit graph now and look at the x-coordinate where that graph crosses the x-axis. All right, so if I hit graph, let me change my window a little bit. All right, does it cross the x-axis 2 times? Yeah, so those are our 2 answers. So this is one of those answers. This is another one of those answers. Does it go through a nice tick mark that I can just count the tick marks and say it's x equals 2 or -5 like we did in the last one? No. And you're not going to guess. You're not going to go, this looks like 1.5, so I'm going to say it's 1.5. All right, don't be that person. We don't know what it could just as easily be 1.4, 1.45. So graphing also is a problem if it's not a nice whole number. All right, and again, what we're trying to think of is eventually not all these methods work for every single problem like number 1 did. So if I ask you to graph this one, let's go ahead and draw a quick little sketch of this. Have it go through, what were those values? About 1.5, and then 1, 2, 3, 4, 5.5 on the negative side. So go ahead and graph that. So 1.5-ish, and then a -5.5 on the other side. We're going through it, but there's no way for us to know what that is based upon looking at the graph. You'd totally be guessing. All right. So those first 2 methods, not so good for this one. Go to Clarita, and let's write the equation again. So Clarita is the x squared plus 4x minus an 8. Clarita is the factoring method. So Clarita likes to factor. I like to factor. I've been telling you factoring is the easiest. So now set that equal to 0 and factor that. Okay, anybody come up with those factors? No, that'll keep you busy for a while, right? In terms of getting a -8, there's no combination of numbers that multiply to be a -8 that will also add up to be a 4. So right now we have struck out with the table. So let's kind of strike 1. The graph doesn't do us a whole lot of good. and factoring doesn't do us a whole lot of good. All right. Now, factoring is the easiest. We talked about this a little bit yesterday. What you are then stuck with is either the quadratic formula or completing the square. Those two, even though they're long, more involved, will work all the time. You will be able to solve every equation that way. So now it's really up to you. And that's kind of what the next homework is. Tahani uses what did she use? The quadratic formula, I think. It doesn't matter. One's the quadratic formula. One of them is completing the square. Those are the only two ways that you can solve this problem. And you have to now decide ultimately long term which one is going to be your best bet. All right. So what you're going to work on now. So kind of do this now. This is also going to be your homework. So you can get a lot of this done right now. Finish this problem number 2, knowing that the table doesn't do us any good. The graph doesn't do us any good. Factoring doesn't do us any good. And then you have to decide, do you like the quadratic formula better? Because that's one of the other options that will always work. Or do you like the square root method, finding the perfect square and then isolating that, taking the square root of everything? The next page then, completely up to you. When I say determine the best method, that could vary. What I mean is pick the method you like the best that will work for that problem. Totally up to you. So there are 6 of these. I can tell you the quadratic formula works for all of them. The completing the square works for all of them. But if you can factor it, factoring is usually going to be your best bet. Okay? So that's your homework now, is kind of looking at these and identifying what's our best bet. Does it factor? Does it not? And then executing whatever method you prefer. Okay? All right. Now I'll turn you loose. Try this. If you have any questions, let us know. Ask somebody around you. See what you think. Because this now is putting all this together. This can be a little bit interesting here. Yeah, thank you.